those kind of places, we don't really want an API. So those things are like, that should be happening right away. So predictive search to theme the user based on their mood, how they are reacting, their context and all. But again, any technology out there comes with a trade-off. So yeah, they have few drawbacks, like, it is like a limited compute and we have to do careful optimization, which we will dive in deeper in sometimes. Before even starting, we all get this question. Why would you run a machine learning model in the browser for that? Is it the backend not enough? Isn't going to get my job done? Right? We all have this question. Well, there are many things that gives an edge for this, for running an ML model in the browser. The first thing, no API calls. Everything, every magic, every machine learning magic happens right in the browser. And it is super private. This can be leveraged where we respect the user privacy the most. We're not going to sell the data. We're not going to take the data. It's going to just work right away like a magic. And yeah, this is the best part. Your feature will work even when there is no internet, when your device goes offline, when there is a very limited bandwidth. It's your feature is still gonna work, and obviously, it's gonna cut down your cost. So finally, our finance team will smile at us. So yeah, before getting started, talking about this, I would like to ask, have anyone heard of this word WebAssembly, or have you something like, have you built something with this WebAssembly? Yes, heard about it. More response. Just want this to be, awesome edge, something like that. Yeah, yeah, yeah. Cool, cool. Everyone's heard about that. All right, we will look into that as well. So WebAssembly, awesome. Oh, that's wonderful. The maintainer there. Wonderful, wonderful. Cool. For the rest of us, yeah, for the rest of us, WebAssembly, we can think it of like, as a some, I mean, audible. I
Yeah,
can,
you are. Yes, please
yeah,
continue.
yeah, thanks. Okay, good. We can think of WebAssembly as an engine, like we can run literally any language in the browser right away. And that happens in the back thread, like that happens that doesn't disturb the main JavaScript thread. And that is how, with help of WebAssembly only, this machine learning models in the browser works. But why would like TensorFlow or any ML model use WebAssembly for that? Right. This WebAssembly is something is, it's one of the best use case for this machine learning. Like they've done a really good job choosing this, because when we run something huge in the browser, right, the browser is going to die, obviously, right? Because this is a i7 machine, and this is a 16 gigs machine, and this might not cause any issue. This may cause any minor issue again. But will this run in a 4 GB machine? That's a question. So yeah, that is why we are using WebAssembly to make this machine learning happen in the browser. Why WASM? WASM is nothing but WebAssembly. So WASM provides native Node.js speed, like they are performing as par to how Node.js performs. So it's like doing a far, like, it is giving a throughput more than 240 MB per second, which is like great. And it is going to, make our feature work much reliable and much faster. Right. The real question of our actual topic of concern, how do we achieve hyper personalization in React? That's a question, right? First, we are getting started with choosing the right library. So there are a lot of libraries to achieve this. One of them is TensorFlow.js. Everyone knows about TensorFlow, right? Yes, 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 yeah, yeah. Good. So TensorFlow is basically is a library that is developed by Google for for performing complex machine learning things. Yeah. So using TensorFlow can be a like choosing TensorFlow JS is nothing but running a TensorFlow model right in the JavaScript. Like it's just a library. So they have a very active community and it has a lot of extensive models that you can use right in the browser. But there is like some cons. It's like it is so complex sometimes. It's not like very beginner friendly. And the bundle size are like so huge, which is like not a very good option for if it's not the right place that you have to use for. So that is best for, when we have complex machine learning things involved, we can go for this TensorFlow. When we are having our own custom models, we can use TensorFlow as well. And we have Onyx.js. Onyx.js is also a library which has a cross-platform compatibility, cross-platform and cross-framework as well. Like if we're not only using TensorFlow models, if we are going for any PyTorch or if we have even our own models, we can like integrate all the models in the platform, and we can like do a lot of things with that. Like the projects that are involving cross-platform machine learning, we can go with this on Next.js. Then like the community is not very active there, and there is like very less examples. Like we'll have to dig in more deeper to get stick with this. And we have ML5JS. It's like good for some prototyping or some demos kind of stuff. So it is not very scalable, but it's like very easy. It's like simple. It's as simple as an API call. So this can be useful like when you're trying out the stuffs. All right. And this is how in-browser machine learning inference works. So we first start with loading the model. And as soon as we load the model, we are going to pre-process the input. Like we are going to, clean the data, remove the outliers. We are going to, making the data, fine tune the data as in the machine learning model understand it's better. So like we can get the better output. So we are going to run the inference. This is where the machine learning magic usually happens. So once we get the data, we are going to do some like we are going to modify the data in the way we want. We're going to just some post processing stuffs. We are going to do that, and we are going to render that in the UI. So this is how the machine learning inference works in the browser. So we will see how we can do that in React. All right. So how many of you have used any ML model to uh, in React previously before this? Or is there anyone who used any cloud services, any third party services for that? Priyanka has used cloud services. Yeah, that's what we all do. ML5 teachable machine in 2019. Yeah, nice, cool. Yeah, OL Lama is also is like that's a very good thing that we can run in the things. APIs, Grok APIs. It's nice. Like guys, like very cool. Like people are, very active here, and I like the energy. Cool. We'll continue with this. So yeah, for the people who have used cloud or API when you don't want to do, right? And trust me, you're not never going to go for any cloud services and you're going to pay them hefty when you can do it yourself right in the browser. Good. So first we are going to start with importing some libraries. In my case, I'm using Onyx and I'm using something called Bird Tokenizer. Before I proceed with the code, I'll tell you what I'm going to show you. So I'm going to build a UI that is going to the theme, the color, the structures, the layouts and all is going to be dynamic, is going to be adaptive to the input that I'm giving. Whatever I'm typing, it's going to understand my emotion. It's going to like infer my emotion. And if with the help of that, I'm going to make some UI stuffs. So I would like to show you the code as well. Like I have something called bot tokenizer. So Bird Tokenizer is something that Google developed. So it's a open source thing. I have used that. Like I made a some modification for that to make my demo work. So they have some things over there. So this Bird Tokenizer usually gets our input and turn that input into tokens. So which I will walk you through here. So this is going to be like a boilerplate that we have to like use for any ML model integration right there. So yeah, we are going to initialize the session and here we are loading the model that we have trained. And yeah, on every component mount, we are going to load this model. Good. So yeah, we have some pre-processing over here. So why we have to pre-process? That's the first question. Don't we just, I'm having the word. I cannot just like feed it to the model. Why I have to tokenize it? Well, you and me can understand English text, but machine learning models can understand only tensors, numbers. So we are going to, encode it first. Then we are converting that as tensors. And this encode input function is going to return me the tensored version of my input. And I'm going to encode this input over here. Like I have some method called run inference. This is going to run the inference for me. It's going to get the input. It's going to throw me the results. And from the results, I'm getting something called logits. What is logits? Well, logits is kind of confidence score that the model gives me to tell me like how accurate this emotion is. If I'm telling I'm very happy, it's going to tell me, some joy. You're like happy. That confidence score a bit high, and the confidence scores of I'm very sad or I'm annoyed. Those kind of things is going to be less. And I am mapping that with something called as emotions. So I'm having a emotions array. So from that, I will be like storing the data. And then, yeah, obviously I'm going to set the prediction. And based on whatever the prediction is, I'm going to render the UI. This is just like, basic thing that I can do. Trust me, the UI is going to look much better. All right. We will see some these things in action. Before that, I would like to walk you through this code. Is it visible now?
Yeah.
Yeah, it's visible.
Yeah. All right. So
Whether
we are
I'm doing
starting.
time check, Vishnu, just a time check at the top right. Um,
Okay.
check.
Sorry.
Just have a type check, like we have around 3 minutes. Yeah, but you can take
Yeah,
some.
yeah, yeah. Yeah. Type check. You know that is going to stick with us forever. So yeah, this is not going to like cause any issue. This works. This is not like any problem. Yeah. So here I have like I'm rendering this UI over here. Like I have an input card, and from this input, I'm going to show this in this frame of motion. I have something called content recommendation. And this component is going to get me this recommendation item, which is nothing but it gets me the recommendation like whatever the model is recommending me, like whatever from the emotion that the model predicts is going to give me the item. I have those things over here, and like few components that does some stuffs. And here are the some I have some hooks over here, this is for like getting the content recommendation, and this is to analyze the emotion. And here's where we do those stuffs that I showed you over there. Like we're going to store the results. I'm going to get the top, like whatever the top emotion is, and I'm going to set the state. And yeah, I have some stuffs going over here. And here I'm going to set the mode, like whatever the user is based on. And yeah, the theme is going to be set over here. Let us look that into action. All right. So this is how our UI looks. So before this, I would like to show you there is not going to be any API calls done. This is just the bot tokenizer being initialized, and this wasm thing is being fetched. Yeah, I have trained this with help of again Google's this dataset Go Emotions. This is a very good dataset. So I have trained it like, let us look something into action. I'm gonna say I am very excited about Meetup. See, this is detected I am in a joy mode. I will say I'm very excited to learn about AI. Cited. AI React. So yeah, look at the speed. Like it just renders the result in less than 14 millisecond. But we can do this, without internet as well. But unfortunately, I cannot, turn off my Wi-Fi. This is an online session. Cool. Let us try out with something different. I'm going to say, um, I'm not good at learning something. It is frustrating for me. It has figured out I am in a sad mode, and I'm in a reflective mode. So this is even recommending me some content like how you cope up in difficult times. And yeah, can someone give me some prompts that I can put over here? Anyone, anything? Just show your creativity. I'm feeling hungry. Okay, let us try. I'm feeling hungry. Oh, I'm hungry, but I'm not balanced and calm. If I'm hungry, what would I do? Feeling hungry. I'm angry. See, again, this is came here. What did this do? Hopeful and driven. See, the best thing over here is it even understand the context. Like it just doesn't give me what, like the emotion is not being rendered just based on what I'm typing over here. If I'm typing angry, see, if I'm just typing angry, it will be like something different. Okay, maybe I will check. We can refer over here. I have some things set here, right? If these are the number of emotions that this particular model can handle. So this is just a person is tired of, okay, sure, Dhanush, we will try it out. Okay, this is just a way, this is just an example of how we can leverage this thing, how we can make the very best out of it. Just imagine you're developing any feature that does a way better job than this. Maybe like we are having a dashboards, we are having a, like something like Amazon, something like a e-com platform. In the e-com platform, it is just going to read my emotion, not even with help of text. It is like I'm loading some camera, like I'm going to like smile at the camera, and the content is going to be like the thing that, like, when I smile, when I'm happy, it is going to recommend me content based on how I'm doing, like what my context is, what is my, like, I'm very active, like I'm very changing, like if I'm happy now, I might be sad after a few minutes. So this is going to be so dynamic, and we are going to make most many things over this. And this is just, a small, it's just an example how we can leverage the AI. A person is tired of their day-to-day routine. I'm tired of daily routine. It always gives this. So yeah. All right. So yeah, this gets better as we train more data. The more we train data, the accurate the model is going to be. Cool. I think I'm running out of time. I'll quickly try to wrap it up. Good. So we have saw how we can leverage AI, how we can leverage the power of machine learning in the browser without any APIs, as I promised you. Now we will discuss some performance and privacy trade-offs and some best practices that we have to follow. Before that, I would like to ask you a question. What do you think that matters the most? All right. Does matter the most when we are building a UI? Does it have to be accurate or it has to be fast? Accurate. Why coder so fast? Cool. All right. So just think of something. Now we are giving a accurate results after a few minutes of loading, or like giving a little arbitrary result quickly. Both. That is a question. That is, yeah, that's right. But like, if we think of it this way, you know, if we are waiting for if we are waiting forever just for the machine learning model to load, what would we do? And I'm very sure when I told you about I'm going to load a machine learning model in the browser, the first reaction, the first thing everyone would get into their mind is like, why would you run a machine learning model in a browser, man? That's going to be so heavy. Isn't that going to be like again, it's going to be like taking forever just to know the model. If it is like happening like that, what we do, right? But with careful optimization strategies, and we can like do some performance like tuning stuffs to make this better. So how many of you have been through the situation? Like we get something, like some issues in the work, like we get some errors or something, and yeah, suddenly we think of it all night when we are eating, when you do everything, and like fine. Right? Yeah. So after hours doing this, we have figured out some very good performance optimization stuff. What we can do? Well, the first thing that we can do is we can quantize and compress a model. We can consider this as compressing a video. So we have a 2 or 3 gigs of videos, and if compressing that, that's going to be reduced to some 200 or 300 MB. Obviously, the quality of the thing, like quality of the video, the bit size of the video, everything is going to be get affected, but it's going to be fast. It's like it's not going to be like pixel perfect as that, but still It is going to work and it is going to give me a real impact. We cannot compare the same thing in UI stuff because, you know, even reducing few milliseconds is important for us. So we want the users to, get React so fast. So we are having React, right? We have to make the React actually react. So that is what we're like our actual things, right? So if it is a small CNN model, if we quantize it for some from 5 MB to 1 MB, it is going to reduce 200 to 400 milliseconds, which might sound like a very less time. And just imagine the time that we took to, predict my emotion. It was just less than few, like less than 8 to 10 millisecond in an average, as far as I tested all these days. And if we reduce 200 to 400 milliseconds, it's going to be huge in perspective of UI. And if it's a medium MLP model, it is going to, reduce up to 800 to 1000 milliseconds sometimes. If it is a large transformer model, it is going to reduce seconds, 1 or 2 seconds, which is, yeah, it's a boon. Then we can consider lazy loading models. I'm sure, like, if you are a React person, you would have done that. Like, we would lazy load, we would not like, lazy load everything. Like, lazy loading a machine learning model is a good practice that we can, follow here. And we can memorize some expensive computations, like the things that are done by web workers or some this WASM stuff and all. We cannot like afford to run that again and again to the computations. We can use our our like most what do you call it? The hook that we love the most, use memo, that we can use to compute like bit memorize it. And yeah, we can use web workers for ML computation. For the people who are not sure about web workers is basically something that runs without like disturbing the JavaScript main thread. So it's going to be like this guy, and it's going to make the stuff work for us. These ML computations and all can be used, like can be leveraged with the help of web workers. And yeah, something that we hate, we have to A/B test. I know this is not very like every. This is not something every developer loves to do, but we have to do sometimes to get the most out of this model. All right, and we have to make sure this interfaces are being accessible to everyone. Accessibility is something that we have to pay more attention to here. So yeah, that we can do. Cool. There are a few limitations for this as well. Before talking about limitation, where do you think we can leverage this machine learning running right inside the browser? I want your creativity a little bit.
Vishnu, sorry to interrupt. We need to
Yeah,
stop
Tapas.
because we're already late on this one.
Oh, cool. All right. I will then quickly walk through this. So the limitations of this thing would be we have to do heavy computation on weaker devices. So that is not a very good thing, but still with some good like optimization, we can do that. And model sizes, we need to optimize it again. And the very important stuff, this machine learning model cannot have data persistent. Once we reloads or once the user leaves the browser, the context is lost. So it is very use case sensitive. We have to apply this only in the place where we cannot afford to go for a backend, or having a backend is not just a real reliable solution. We cannot just like use this everywhere. So it is not a very good thing that we have to do. And we have to respect users' privacy and transparency. Yeah. So as I told, we have to start with clear use cases. We have to use this feature only in the places where it matters the most, where it actually creates very much impact. And we can use, like, choose the right approach. Like, we can use pre-trained or custom models based on our requirement. And yeah, obviously we have to optimize it. We have to respect the users' privacy always. And accessibility. This is something we should not exclude in nowadays UI that we are developing. And we have to test it, to refine it. Yeah. So yeah, this is going to be something that everyone is going to be using in the next few years. So as Tapas said, this TensorFlow JS is there since 2019 or 18. I'm not sure like when it was founded, but like my point is we can leverage this thing for various things. Now we are developing hyper personalized UI with this. This is not going to stop only here. We can develop adaptive and emotion aware UIs. And yeah, this is going to be React devs most like native. This is something we are going to be using natively. So yeah, so that's all for the day. Thank you so much again for making this time in a Saturday evening. And you can find me anywhere, like just my name, Vishnu. So yeah, if you have any questions, you can always reach out to me, send me connection request. I'll be available in LinkedIn. Yeah,
Sure.
thank you.
Thank you, Vishnu, for this awesome talk. I'm sure, we learned something new today from your talk, and thank you for all your time. So we'll quickly move on to our second talk, which is by Shubham Bhattacharya. And he's an AI-driven creator, and he likes to create things, world-ready solutions. So Shubham, if I'm not wrong, this is your first talk.
Yeah,
Uh,
it is my first talk.
yeah, so I want all of you to give all the support to Shubham and let it be a rocking talk. Shubham, please, stage is yours.
Yeah. So thank you everyone. And so let me start with the presentation. Okay. So the today's topic means I'm
Shubham,
going
I
to
think you
talk.
have to share your screen. You have not
I
shared the
have not.
screen. Yeah,
Oh, sorry. 1 minute.
that's fine.
Yeah. Is it shared?
Coming up.
Yeah, coming up.
Okay.
Yep.
Thanks.
Then go ahead.
Okay. So the today's topic which we are means I'm going to tell about the session is or means I am going to talk is neural networking. Okay. So the topic means the title I have choose is keep calm and getting neuroned. Okay. So hi, I am Shivam Bhattacharya. I am currently an SWE intern at Anandabazar Potrika. I also am research intern at the CRDTH lab at IIT Kharagpur. I am a 2H hackathon winner and 8X ideathon winner. I am also the founder of Hacktropica, which is a hackathon which is organized uh, in Asansol. The thing is, I'm just an AI guy and I like to be a pirate king, means I am with love with animes and this is my LinkedIn. So चलिए खेल को आगे बढ़ाते हैं. So this is a quote or something which is given by Griffith Hinton, who is the father of deep learning. That is, neural networks are universal approximators. They can approximately 1 minute. Yeah, approximately function any degree of accuracy. Okay, so this is a generalized term which is given by him, but I guess this is not clear to everyone. So let me give you a simple thing. So what neural networking is, if we want to know or what does it means? 1 minute. Yeah. So neural networking is like a computer system. So what it does, suppose you are given a picture of cats. Okay, you are just taking a baby and you are teaching him what cats are. What he learns, what a cat looks like. When you give the voice of something, it gives the recognize the speech. Suppose a baby learns how his mother talks or his father talks, and by that he can easily recognize who is his mother and who is his father. Same wise for the neural networks also, it is a revised definition I have produced, which is if you take the example of emails and you train the model, what happens? It detects spams. So you can just think of it as a digital version of tiny yes or no switches, nothing more than that. So this is basically a neural network. Let us see an example. This is a cat. Okay, the cat has eyes, ears, pupils, the arch. Okay, so if I say that I will give you 2 ears and say which of them is of a cat or a dog, you will see the first one is of a cat and second is of a dog. If you train the model in such a way, it can easily see the features or get the features and can tell you which is a cat or which is a dog by seeing the faces. So this is a meme. So one does not simply find all the things in the internet with cats, because the most of the things you will see are examples in neural network are given on cats only. Also, a question arises, where will we get the data? Suppose we are training a model in neural networking, where will we get the data? So for that, never ask a woman her age, never ask a man about his salary, and for an AI company, never ask where it got its data source. So this is a artificial neuron. So the structure is given totally here. We have the inputs, the weights, the summarization function, the weighted sum, which is given, the bias, the activation function, and the output. The output is basically the prediction which we are getting. Okay, so I will tell you everything about it, what is it means or not. So let us see what is the input. What the input does is it it is the data which enters the neuron. Okay, so what we are entering or what we are giving the data, it is generally represented by x1, x2, x3, dot dot dot. Weights are what it gives us stress that how much the inputs are important to us. Okay, so it decides the input, the efficiency of the input, or how much the input is dependent. So many things are the weights are an important part. Third one is the summation function. So what it does, it adds up all the input and multiplies them with their weights. It is a simple function. Bias, it is a small extra value which helps the neurons to make better decisions. Activation function is the most important thing. So what it does, it applies nonlinear transformation so that neurons can learn complex things. It sets a timer. And the last is the output. What it does, it gives a final prediction that what it does. So if we see the picture again, the inputs are we are giving the input or the data where it is shown by x upon n. We are giving the weights. Weights are basically nothing but they are giving the stress that how much the inputs are important. The summation function, as I have told here, is basically the inputs multiplying the weights. The activation for the bias is given, it is bias is given as an extra value, nothing more than that. And the activation function is the main thing which activates or predicts and we get the output. So the question is, when we are talking about human neurons, they think. So how does a like a neuron or an artificial neuron thinks? So it depends on the artificial neuron decides output by this formula. Output equals to activation, input into weight plus bias. This is the formula. If we use this, we get the output. And from that, we can predict a thing. But a problem arises that anything, but if we do one time or we perform the we use the neural networks to predict a thing, not always the correct thing comes out. So what can be the solution? So these are the layers. Let us see the layers and we will see what are the functions we can add or what we can see. So here are the input layers. What we do, we enter the data from here in the input layer. The hidden layers are basically the layers which mainly does the work, and the output layer gives the output. The input always comes with the variable X and the output with the variable Y. Now, we have the three devs or the functions. What it does, first is the creator, which is the forward pass, which is the thinking phrase. It is like tells that if we are doing our work, suppose This is a layer of the neural network. We are giving an input. It does the work and gives me the output. Okay. So this is the creator or the forward pass. It is a thinking phrase. Second is the preserver or the loss function. So what it does, while we are performing a function or doing something, we are getting a problem or we are getting a loss over something. We detect that, and that is the work of the detect loss function or the preserver. The destroyer, that is the back propagation. Okay, there is the learning phrase where we go back to the place where we had done the error, and we can again train the model, and by this way it forms a continuous cycle. The forward pass, what happens? We enter the data in the input layer. Each layer performs the calculations how we are doing, and the predict comes to the output layer. The loss function, what it does, loss function is the like if we are doing something wrong or we are just uh, following some wrong suggestions, what we can do, we can minimize the training by the loss function. And last is the back propagation. What it does, it computes the errors. It sends backward the error, that what is the error, and it can adjust the weight. What happens during when we are just performing a neural network, or we can see a neural network, the weights, the problem mainly arises due to the weights. So we have to arrange the weights or see that what problem there arises. By this, what we can do, we can easily it is a trial and error method. We are giving the inputs. Okay, with the hidden layers, that is the we are doing the back propagation. We have found out there is an error there. We have calculated the error. We are again going to the back propagation. We are making it learn that it is the error, and by this is how the networks learn, how we can learn from the mistakes. It learns clearly from the mistakes, that if there is any mistake or not, and by this it continuously goes through a cycle. So this is the cycle I was talking about. There is a training loop. What happens? We give the forward pass, as we have said. It compute the loss, okay, the preserver, and the back propagation, that is the destroyer. It destroys the previous works. And what happens? It goes continuously. It repeats that. It updates the weight, and it again goes to the forward pass. So this training thing continuously goes on until there is any problem or there is any thank you, Taposh. Uh, so you have any problem or anything we are getting here? Okay. Yeah. So these are some examples of the neural networks in real life, which we can use. That is the face recognition system, the recommendation system, the medical image diagnosis system, the chatbots, the self-driving cars, and the object detection. Okay. I currently have a face detection recognition, but I guess if I will run here, it will take some time. Okay. So if you want, guy, I can paste it in the chat. What I will do means will I paste it in the chat? You can just see it. It's nothing, just a simple uh GitHub repo. 1 minute. What happened here? Give me 1 minute. Yeah. You guys, means I have just made it. You can just try it and see. It is nothing, just a basic face emotion detection. So what it basically does is when you give your face, or like you in the local area, it is means I have used a local model only, just from and what it does is it gives you a happy, sad, or angry face. Or what it does, it basically uses Keras, TensorFlow, and OpenCV. And I have used Streamlit here because it is easy to detect, or you have any problem, it can easily be done. Give me 1 minute. Yeah. So, do you have any questions? If anyone have any questions, you can ask me.
Thank you, Shubham. Yeah, I think we are seeing in the chat that great presentation. You explained
Thank you.
everything very well. And this was your first talk, so I'm
Yeah,
sure there are going to be many more in the coming future.
thank
So
you.
stand by and see the chat because people will be posting question there. So if anything coming on today, please.
Okay. If you guys want to like ask any question, you can just 1 minute. This is my LinkedIn. You can go to my LinkedIn and can ping me. I'm always available.
Cool. Thank you. Thank you again, Shubham. So we'll move towards our third talk. And after that, we're going to take a very short break, and I'm going to pass over to Shulagna after that, who is our original host. But due to some emergency, he could not join in the beginning, and I was just doing a proxy. So the next person that coming in is Arnab and Arnab Chatterjee, and I guess no one can introduce Arnab better than me because he is my colleague. We work together, and he's a mad guy about technology. You will see it probably in his talk. So Arnab, can you come on camera if you're available, and so that we can see you, and I can pass it to you.
Yeah. Just give me a moment. I'm trying to set up my camera. It's not
That's
turning
fine.
on.
That's fine. That's fine. Can you start sharing this screen? I think that is what more important.
Yeah. Let me get started. Okay, the screen. That's what I'm trying to fix. For some reason, Zoom is not, or my Mac is not letting me. Okay, let me rejoin quick.
Yep, sure. Okay, so by the time Arnav join, right after this talk, we have a small activity. Yeah, so Sulagna will take care of that, and then we are going to continue with two other talks. Before we end the session. Sulagna, over to you. You can probably start talking now and see everything is going fine.
Yes, sure. So, okay, hello everyone. I have joined a bit late, but I hope I haven't missed a lot of things. And yeah, uh, how's the Josh? Like, is everybody's having a great time learning a lot? Would love to do that in the chat section. Okay, is the energy okay? Great.
Let
Yes.
me, yeah.
Yeah.
I hope you can hear and see me. And
Yeah.
yeah, very good afternoon to you all. It's a beautiful Saturday evening in Bangalore. I hope it's in some all the other places as well. And thanks a lot to everyone for joining in this in your weekend to this call. And thanks a lot to Tapas and the other co-host for hosting me and giving me opportunity to share the stage with some of the most prominent speakers and person in the tech that I know of. So yeah, so let's get started. Now let me quickly share my screen. I want to present. Give me a second. Is my screen visible?
Yes.
Yes.
Okay, let's present. Well, sorry for the spoilers, but anyway. Go to page one. It's lagging too much. Wait. Okay. Wrong name again. Anyway, so hi. Thanks everyone again. So today what I'm going to speak about it's covering observability from the front-end perspective that I'm going to talk about. What is front end observability is, I'll keep it very practical and grounded and start from a very familiar place that is in the title, that is console log. And slowly then we will go slowly from there to something that looks little bit closer to what big companies does in production. So let me introduce let me introduce myself first. I am Arnab. I am cloud and backend engineer at CreoWiz, and most of the days I spend writing backend services, deploying and running stuff in AWS, working with Docker, setting observability stacks, doing monitorings and all, and what a infra engineer does, I do that. And the fun part is when something breaks in production, it is me, so mostly, who has to figure out why, where it is coming from, who is affected, how much is the affected blast radius is, and fix it. And yeah, that happens in Friday evening as well sometimes. But yeah, on the other side, other than my full-time work, I am a writer. I write blogs actively. I build my own projects. Something I'm really working on recently is called RepoScript. You all have heard about Toon. It's a little more efficient version of Toon that works only for parsing code bases to save more token for LLM use cases. So that's something I work on, and also I'm just very in love with open source ecosystems, and I contribute to open source repos like GitOps and other few actively, or I try to. Yeah. So I'll show this in later last so that we can connect. But let's cut to the chase. So today's agenda is around developing a mental model for front-end observability. So what does that mean? So we don't won't be developing personal projects for our lifetime, right? Our whatever code we'll write someday will go to a million of people, and they will be using it actively. So to those cases, we want to have some traceability, and I want to give you a model that you keep in mind when you're doing but developing for multiple people. That how can you see what is going on their end? Console log, the browser, only the user will be able to see it. Now you won't call up the user and ask him, okay, yeah, I heard something is breaking in your end, can you open the console log and share the screen? That won't work for some thousand or million users. So we will look at this mental model, that how do we actually set it up in front end to back end to infra level. And I will show you a small React Express setup that is sending log to Grafana Loki, and you will be able to see how the whole observability stack looks like in real life. So before we dive deep, we need to ask this question. What is observability anyway, and why does it matter, and why should I care for if I'm a engineer, front end, back end engineer, right? It's not a feature. It's not something that is going to increase stakeholder value. So why should I care about it? Okay. Uh, so let's zoom out for a second and answer this basic question. So in development, you do npm run dev and you do console log. Maybe if you're fancy, do install logger or something like this, and we are done. But it works on your machine, on your client's machine, but doesn't help the user whose order page is failing during the big billion day sales. Okay, because only the certain users are hit by that issue. Okay, so suppose 10 million, you all know Flipkart, right? Raise your hand if you know Flipkart. Who doesn't know Flipkart here? Anyone? You know Flipkart, right? You buy things from there. And during big billion days, the very common phenomena is you go to order, you try to buy something, and the page goes blank. But for your friend, that might not be the case, because it's not the effect is like the issue is not for everyone. It's a very small or some set of user. Okay, so we need observability to know which set of user is being affected, which certain routes they're being affected, which user pattern is causing that issue, uh, what kind of network, be it slow, be it not very fluent network like 3G, 2G, what they are on, how fast is the device. We need all these matrices in a connected way so that it can comes from your front end, goes to your back end, jumps between your service A, backend service B, a database. You know that journey, what user has done and how that butterfly effect has gone through your whole system and what did that exactly broke, so that you can trace back, know which service, where that service is and how that broke, and you can fix it. Not like otherwise you will have to do all the guesswork. Okay. Without observability, we will be limited to asking user for the screenshot and console log. That's not practical. That's why we need traceability. And that is the motivation for this talk. That's why I built the POC that I'll show. Okay. So let's so that's, I think I have already covered. Okay. So let's go. Okay, why console log, or why struct events and structured logging over console log, or say something similar? Okay, default is, we know console.log error fetching orders, and we know some API is failing, maybe that's why. But that tells us nothing in production. A small improvement to think of in terms of its event. You, instead of strings and failure in your local code, you need to think in terms of event. Now, what is an event? Event is if something is happening in your whole system. If an order is placed, that is an event. If an user has logged in, that is again an event. Say if something breaks, that is also an event because that happened. Not strings. Okay, in moderate scale systems, you need to think it that way, because code is huge, the code base is huge, the services are huge. The only pattern that is consistent is the services, or you provide, and the events conducted through them. Well, and we need to know where that event comes from. Which app, which environment? Is it UAT? Is it dev? Is it fraud? Which API route? Which gateway? What type of event? If it is success or if it failure, and what is the ratio? And timestamp. Yeah, of course. That's why we need to move from console log to more robust logging that we can capture in your backend, or keep it stored and maybe see it uh, somewhere like Grafana. I'll explain what is that. Don't Please be afraid of. Don't be afraid hearing something like that. I will explain everything. So you can then what that will enable you to ask questions. Ask question like, show me all the errors in order that happened in prod in last 15 minutes. So what you will have, yeah, I need to minimize this probably. Give me a second. Okay, I hope my and I'm able to share and show stuff. Wait. Okay, let me fix something real quick. Go back to phone. Give me 1 minute. Okay. Is my screen still visible, or it has closed?
Yes, it's
It is
visible.
visible, right?
Now it's closed.
Now
Give
it's
me a
closed.
yeah. So audio is fine, right?
Yes, audio is absolutely fine.
It is back again, right?
Yes.
Okay,
That's
sorry for the interruption.
No issue, no
Okay.
issue.
How do I minimize it? Okay. So what does this like all means at the end, having this traceability, observability, all that stuff. So what it means is to have a dashboard, something like this. Where'd that go? Okay. And then be able to see what all the event that you got, say in last 24 hours or 1 hour, and how much of that is a success or how much of that is failure. Let me show you real quick something. So let's set it 500, let's 24 hours. And yeah, you can see all the failed stuff. Okay. All the failed stuff I can see in the dashboard and know which time they have occurred. So that's something is used. That's the main use for this observability stuff, but that's not limited to checking what has failed in the back or failed in your system. But the usage is much more robust and impactful. So yeah, let me share the presentation again. And this browser-based presentation is so laggy. I don't know why, but yeah. Okay. So, structured logs, by structured logs that I was earlier discussing, which app, which environment, all this stuff we need to be able to see. Okay. No, not next. Yeah. So, in your logging, that you are transferring between front end, back end, and different backend services, you have these things like which app is that, which environment is that coming from, which route of that page is or the API is, the if the event is failure, or if the event is something like uh, let's say success, timed out something, and session ID, and something more important I'll talk about, that is correlation ID of that log. So what is correlation ID? That's the main question, right? So let's look at it this way. Structured events are great for handling. Like from coming from console log, structured events are already a great step up, but we still have a gap. How do we connect to what browser? How do we connect or correlate what browser saw and what backend did? How do we know that? How do we correlate that? So that's where the correlation ID comes from. It's nothing, it's a simple, stupid, unique ID that we all know and love, and we attach it to a request of an user. Like in from React, if you are building a front end in React, you can with your API requests, you can attach a header like X correlation ID equal to you something, and send it to backend and make sure your backend accepts that in that particular endpoint. So this correlation ID helps that okay, user this particular user at that time clicked this button, that ID was got generated, then that ID came to this service A. Okay, service A. Then service A says it's the order API. Order service forwarded that request to payment service, and payment service also received that single correlation ID, and payment service failed. So when we check the logs, we know it came from front end, went to orders, came to payments, and then failed. So that's the whole idea. Okay. So I will do a small demo. Okay. I will show a tiny React app, small React app built with Vite. It has, okay, let me start it up. Okay. Um, not this, not Chrome. No, page. Yeah. Okay. So let's refresh it. Okay. So this is the demo page. Let me tell you what it is. We have a load orders that will simulate a hit to an slash orders endpoint. Now that slash orders endpoint has a simulated failure. let me show you what I mean. Okay. Okay. Let me show you what I mean. Where that is. Here. So I have something called failure rate. Okay. That failure rate is nothing but a math.random that will fail my hit to backend slash order endpoint, or that slash order endpoint will fail at a random interval, or let's say 10% of times. Okay, my order API will fail 10% of time I hit it, and that way and will we be passing a correlation ID from front end to back end for every event. Okay, and that event will be tracked and logged in our Grafana dashboard. So how does that looks like? We have a basic backend. We have an order API that I shown you. We have some dummy data. Okay, just to show something, and we have a network delay that will simulate to show you. Like in localhost we won't have much delay, but when actual users will be trying to use it, they will have some millisecond of delay that will simulate via delay function, and we'll simulate the fail by this math.random thing. And yeah, that's a basic thing. I won't go to other stuff as of now. Okay, because that is just to support the application. And in front end we have a very lean page. Okay, it does nothing but takes the it shows a button. We click that particular button, we generate a coordination ID, we send that particular coordination ID via our front end, send it to backend, and our backend logs it. And if it fails, we can track it via that coordination ID, which event it came from the front end, and we can see it in, we can search it in logs and see what has happened with that particular ID, how many times it had failed, things like that. Okay, let's not make it super confusing, and let's jump to the demo. And yeah, small thing, we have a Grafana dashboard setup that I just shown you earlier, and we are using Promptel with that to record all our logs that are stored in locally in this logs folder. Okay, so that's what we are working with. So go to the browser. Okay. Now, if I hit that load order, we can see we generated a correlation ID that and the order is successful. So that means order went through and slash order endpoint is success. So let's keep doing it. And at some point of time, we have a failure. Yeah, we have one failure. Let's keep doing it. Yeah, we have two failures. And 3, and we have some correlation ID against that. Now here's the fun part. Now I am an DevOps engineer. I don't know where the stuff failed, which user got affected, or which services broke. So I will simply go here. Okay, I'll simply go here. I will select it. Say set a range, query it, and yeah, we can see something. Let's see, this one probably failed last, I believe. So I'll just query with this that this ID has failed. So if I do it like that, I'll be able to see all the event that happened in that particular system, where it all went. It came from front end, then came to back end, and it failed there. Now it's a very simple setup that I used for demo, but in practice, you won't have a single backend, but you will have an API gateway in the middle, something maybe a load balance, something in the middle. Then it will have 5 different maybe services: login service, order service, payment service, tracking service, all these things. And you need to track which route that user journey went through. So that's why observability is important, and that's what we're doing here. We are moving from just console logs, your device only logs, to something other people can see, and other people like you can see of what other people are doing, and you can take actions on that. Now it's a small setup, but what does big companies do that are not very small? Okay. So, companies follow the same exact pattern, but there is more to it. Okay, more automation to it. So in large system, every incoming request gets a trace ID in whenever it flows through an API gateway or an entry point. Okay, be it a mobile app or React, which initiated it, or an API gateway. Okay, and that acquisition drive, that ID travels through all the gateway, load balancers, microservices, databases, and third-party APIs. And since every log with that ID, they send those logs and traces to a central observability stack. For our case, that is Grafana, Logstack, Grafana, and Loki. For big companies, that is something else. And on-call, the on-call DevOps or cloud engineers they have, they can type an ID of a failing service or sorry, failing event. They can type in the trace ID, and they can see the full journey of that single user end to end. Now, in a big commerce, like what we have covered in a big e-commerce company, user clicks something like place order, front end sends to checkout. We generate a correlation ID, say checkout EU out ID something. That call fans out to multiple services, a payment inventory, order, notification, all that it flows through there. Now, say customer services gets a call that okay, my this page is failing, order payment failed, or I saw an UI, and that customer service guy can go to check the account, see the correlation ID they have. They can hand it to the something like infra engineer or DevOps engineer. They can type it in. They can see how why are they who is facing that, which user group, what is the blast radius, and how many folks where that is originated from. And that is the most important thing, because you need to answer your CTO that where the service is failing, and that's why you need observability, so that you can answer the questions that any stakeholder will ask when a service breaks. Okay. So again, what I have told just now, it's presented in this graph. Uh, just like that, from browser, API gateways to database and multiple services, our API calls flows through, and we maintain that trace ID back to back in the round trip. Okay. So yeah, that is all I wanted to show. Okay. Okay, then goodbye. If you want to connect with me in the LinkedIn, here is the QR code. You can scan, we can connect, and I really hope we all had something to take back from this session and use it in our day-to-day development life, when we are building something for more than ourselves, something that will create value to your life or some other people's life that they will use. You may want to have an observability stack with your application. So that's all said. Yeah. And that's my GitHub. If you want to connect, see all my other projects there, and I will push the code for POC there as well. Sorry for any inconvenience caused, and shoot me the questions. I'll answer it in chats. Yeah.
Thank you, Arnab. Thanks a lot. That
Yeah.
was a great talk, to be honest. But if you have any question, anybody, please post it in the chat section. We will connect with Arnab and we will get back to you with the answers. So going back to the next speaker, we are running out of time, or going a bit late. So we are not going to have the quiz, and we are going straight to our next speaker. And our next speaker needs no introduction. He's a devoted father, tech entrepreneur, software engineer, educator, FreeCodeCamp contributor, WhatCamp speaker, programming enthusiastic, digital marketing mentoring, community building. Oh, I think I haven't missed anything. So let's have a big round of virtual applause for Sumit Saha, founder of Learn with Sumit, logic-based labs and Analyzen. He will be introducing us with a brand new caching revolution in Next.js 16 caching components, rethinking caching for modern web. So Sumit, stage is all yours.
Thanks a lot, Shuragna. I think I'm audible. First of all, please kindly confirm.
Yes, you're very much
Yeah.
audible.
First of all, thanks for the too much introduction. I think I don't deserve that. I think we have Taposh Dai here. He's a big brother to me, and he invited me. He gave me the opportunity to join here. That's everything I can think of, and definitely it's an amazing organization, and the event is going really good. I was just listening to the previous talks, and those are amazing. So I'm a bit nervous, and the topic is very advanced. So the main challenge from my side is to explain this complex topic within 20 minutes. So I have really very small time at hand. So before doing any introduction or anything, I'm just going straight into the code. In fact, I wouldn't have that much slides. So mostly I will do something hands-on, and then if I get any time, then I will talk. So first of all, let me share my screen. So, Shulagna, could you please confirm that my screen is visible or not?
Yes, the screen is visible.
Thank you. So I think Shuragna has already given my introduction, so I would not go into that detail. In summary, I am actually a YouTuber. That's my current job role right now. So just like Taposhda, so I have two channels. One is Bangla, so that is Learn with Sumit, and recently I have opened an English channel called Logic Based Labs. So if you guys can check it out, those. And I also run a company called Analyzen in Bangladesh, which is a digital marketing company. So we provide digital marketing solutions, fintech solutions, and everything. So, and if you need any information about me, you can just go to www.shumitshaha.me. That's my personal website. So that's it. That's it from my introduction. So now and this is my Learn with Sumit YouTube channel, and this is the Logic Based Labs English channel. So now let me just minimize the Zoom things. Okay. So today our topic is cache components, right? Next.js cache components. So we already know that this is an advanced concept, as you know. So Next.js 16 has recently dropped a new feature called cache components. And to know this session, you have to have a preliminary understanding about Next.js. Even this is an engineering level topic, so I would try my best to explain as much as possible, as beginner friendly as possible, but definitely you would need some kind of understanding about Next.js 14, 15 or Next.js caching, how it works behind the scene, what is server-side rendering, what is a static side rendering. So if you don't know them, so I will definitely share a resource at last so that you can check them out later. And also when you get the recording of this session, you can then just join them together and you can study. So let me explain what cache component is. So cache component, as described in the Next.js documentation, cache component lets you mix static, cached, and dynamic content. That's the main part. So the mix word is very important. Back in Next.js 14 and 15, we had to think at page level. Like we have different pages. So, and different pages mean different routes. So all the things that we have to think, like the caching, the rendering strategy, everything were dependent on page level. Cache components first time makes it possible to think at component level. That's like a fine grained control over everything you have. Okay, so let me explain a bit. Sorry. So consider this is a React tree. When we go to any web page or any React application, for example, something.com/home. So you will land to a home page, right? So that home page is basically a React component and it has other subcomponents as well. So consider that home page as a set of different components. So in the slide, you can see the yellow mark components are actually static components and the blue mark components are dynamic component. What do I mean by dynamic component? Those components can fetch data can query from database, or do some stuffs like dynamic things like real-time information, like accessing the cookie or header information or anything. So previously, if we need any dynamic things in any components, if we mark this component as dynamic, the whole entire React tree becomes dynamic. So it will actually, instead of getting rendered statically, it would have rendered dynamically. That means the true SSR. That means in the build time, we will not pre-render the entire page. We will have to render it as a dynamic page or a true SSR. That what we say. So that's the thing that we already know from Next.js 14, 15 and older versions. But first time with cache components, we can actually change our mental model. There is a change in the mental model. Previously, Next.js was doing a lot of magic behind the scene. Next.js tried to make any page static as much as possible. So the mental model was Next.js automatically doing things and try to make things statically for better performance. But in the developer community, they were kind of disturbed about that, because, for example, suppose in this blue component, in this component, you are fetching a data. But fetching a data doesn't make that component or the React tree dynamic. So for example, suppose you are fetching a data in this component and suddenly you reload the page and you are not getting the update. So it was confusing. We all know that Next.js was kind of unpredictable. It was actually not unpredictable. We didn't know all the nitty-gritty things behind the scene. That's why we felt that it is unpredictable. But with Next.js cache component, recent component, everything becomes kind of predictable and we get component level control. Previously, our mental model was most of the time Next.js will try to make things static and we had to mark any component dynamic. But with Next.js cache component, the mental model is just opposite. By default, Next.js will consider everything dynamic, and if we want to make any component static, we have to mark it. Okay, so that's the first change. The change in mental model is there. So just consider this website. For example, this is taken from the Next.js documentation. So here is a website and this is a product page, an e-commerce product details page. And here you can see the pink area is a static area and the blue area are actually dynamic area. So from the view, we would expect that this product information will not change frequently. So we want to keep this area static. And also the blue area, these needs to be dynamic because this is the cart area. So this is a personalized area for the user. The cart count can change. So this needs to be dynamic. And below there is a recommended section, which is also personalized for the user. So this needs to be dynamic as well. So now we can think different components differently. Previously, we had to think to make the recommended component dynamic, we had to make the entire page dynamic. But now we can just keep those pink area static, and we can even we will see the demo a few moments later. Then we'll see. So this is the recommended area. To make this dynamic, we wouldn't have to make the entire page dynamic. So that's the simple thing. Now, so this line is very important, and this was taken from the documentation as well. This will give you a very good idea that we are getting a granular control over what gets cached and what doesn't. Okay, so we have the control at component level. So we can mark which one to keep it static or which one to make it dynamic. Previously, most of the thing was automatically done and too much magic was happening. Now, Next.js gave us the control towards us that you choose which one you want to cache and which one you don't. Okay, and instead of the component level, instead of the page level, we will do that in component level. So for example, let's get back to this example again. Now with cache component, we will actually, this pink area will be rendered from the build time HTML output. Okay, this pink area will be rendered statically in the build time, and when a user requests this page, this will be cached, and the cached resource can be served from the CDN or any content distribution network. Okay, and these dynamic areas will be streamed in you may have heard about Next.js streaming. So if you don't know these topics, I will definitely share my resources so you can combine them together. But right now you can consider streaming as a dynamic thing that after when page loads, it will parallelly request those resources like this dynamic part individually from the server side. Okay, so that's the thing, that's the summary, that's the kind of top level view of Next.js cache component. And this strategy, this layout strategy or this rendering strategy is called partial pre-rendering. Previously, Next.js introduced partial pre-rendering or PPR back in Next.js 14, from Next.js 14, and it was an experimental feature. But right now, actually, the partial pre-rendering is related to the Next.js new cache component. So basically, they have removed the partial pre-rendering experimental flag, and now we will control partial pre-rendering with the cache component. So if we enable cache component in our application, we will get the partial pre-rendering as well. So actually, Next.js cache component will implement partial pre-rendering directly. Okay, so we will see the example, then you will understand. So finally, I would definitely say the benefits of cache component, these are huge. I have already explained. So basically, we are getting component level granular control. The second one, we are getting the static shell very quickly. We are getting dynamic content. At the same time, we are using the beauty of static shells, like the static parts as well. So the static rendered benefit is also we get, and at the same time we are getting the dynamic part as well. So we are getting faster, fast contentful paint and time to first byte. Okay, then as I said, that Next.js became more predictable. Caching and revalidation, these things are now much predictable. Now you can understand whether this will be cached or this will not be cached, even in the development mode as well. Previously, in the development mode, we had to suffer a lot. And finally, it implements partial pre-rendering, and we don't have to understand partial pre-rendering separately. We will combine it together in Next.js cache component. Okay, so that's what the best of both world kind of approach that cache components and PPR together solves. Okay, so now it's time to go to the example. So I will try to explain in the example as much as possible. So I will stop my presentation and let me stop it, and I will share my screen of my code screen. So just give me 1 second. Okay. So I think Shulagna, could you please confirm that whether my screen is visible or not?
Yes, it's visible.
Thank you. So let me remove the zoom floating materials. Okay. So I have a simple Next.js 16 application. So Next.js 16 means I have installed it, just npx create next app, the way we do it. Sorry for my Bangla, so it's interrupting. So
We loved it. We loved it.
Okay. So I think everyone is everyone understands Bangla here, so no problem at all. We love this language, so it's
Yes.
natural that it will come. So okay, so we have a simple Next.js application. I haven't done anything in the layout file or anywhere. I have just changed some code in the page.js file, and that's where we will code. Okay, so this is the home page. Okay, and this is the browser output. Here you are seeing that just a heading tag and a simple green box. So the heading tag is coming from the h1 tag, and this is the static content, and this data is coming from this fetch request. Okay, so in the component level we have fetched the data. Okay, simple stuff. We do this every time in Next.js 14, 15 and previous versions. So our expectation is it will work, and it's also working. Okay, now we will enable Next.js cache component here, because right now Next.js cache component is not automatic. We need to enable it. So Next.js gave us the option to enable it or disable it. So if you want to use cache component, or if you want to update your previous application like Next.js 14 or 15 application to Next.js 16, you can just turn off the cache component feature, and then it will work as well. So they kept it for backward compatibility. So first, what I will do is Okay, so let me explain the fetch API. This is just a random word API that I found just by Googling. So if I go to this URL, every time we hit this URL, we will get a new word. That's why this is called a random word API. Okay, so where is my screen? Okay, so okay, so let's get back to the code. So now we will first enable Next.js cache component. Okay, so for that we will have to go to the Next.js config file. Okay, here we will have to say cache. Okay, and I will get the suggestion cache components, and I will make it true. Okay, the moment I do that, now cache component and partial pre-rendering feature is enabled in my Next.js application. Okay, so I don't have any work left here, so I will close this. And now, as soon as I do that, you can see I have error. Okay, why? You can see if I go to the browser, you will also get the client-side error as well. And there you can see uncached data was accessed outside of suspense boundary. What that means? If you can recall, in the presentation, I said we have to change our mental model. So our mental model was previously we were just fetching a data, and Next.js was statically rendered this page, right? Because Next.js thought this is just an API call. This is not a true dynamic thing. Okay, so the mental model previously was Next.js tried to make it more static as possible. Okay, so it previously considered this as a static page, but now the mental model has changed. Now it considers everything as dynamic. Okay, so now the URL is actually dynamic or server-side rendered or SSR. Okay, that's why it's giving me the error, and it says that uncached data was accessed outside of suspense. Uncached data means this is the uncached data. Previously it was cached, but now it's not cached because I said that we have to explicitly mark this page as static or mark this fetch request as a static. Okay, so to solve this problem, we have to just bring in the cache component directive, that is use cache. Okay, if we do that, you will see now the error is gone. Okay, and if we reload the page, everything is fine. So what does this use cache do? This use cache actually marks this page as static. So we are manually marking this page as static. And Next.js by default considered it as dynamic. And as it was dynamic, for performance reason, it gave me a warning or error that this page needs to be dynamic. And you are doing dynamic things. So use suspense. So wrap it with suspense so that I can stream the response. Okay. So that's a beautiful feature. You can understand that. So, and this use cache can be used in the file level, like at the top of the file, or we can put it inside the function as well, or in the component as well. Okay, so if I have multiple components in this file, which I will have later, so in that case, you can manually just pass this use cache to this component only. Okay, so if we do that, the output will be same. Okay, so if we think about the tree that we show earlier, suppose this is the home component or this is the component, and there I have marked it as use cache. So this is the static component. Okay, and if we don't mark any component use cache, then it will be dynamic. Okay, but one thing I need to point out here that for example, just fetching data, like this is a dynamic thing. Like, so if we remove this fetch and just cut this from here, if we don't have anything dynamic here, and if I have something static here, for example, let's say data or hello world, then the error will go. Okay, that doesn't mean that this page is dynamic. Okay, Next.js, now the Next.js intelligence will come into play, and Next.js will see that intelligently that this page is absolutely static. There is no dynamic thing at all. So now I can completely render it as static content. So this time Next.js intelligent or magic will come into play, and it will render this page as static. Okay, so but if we do any dynamic thing like before, like the data or fetching something, then definitely this needs to be wrapped in suspense boundary. Okay, so this is the way we have already marked this component as a static. Now we we use the use cache, and now for example, let's say, how can I say? Okay, so now let me take you to a diagram to explain a bit. For example, this one. Now our task is to have multiple components in the page. Right now we have only one component, right? And we can mark it static, but we can have multiple components, right? So right now we are not using the partial pre-rendering feature. In ideal scenario or in real world applications, we would have different components at different level. So consider this page. This is a component, this is a component, this is a component. So I want to mark these green mark components as a static and these ones as dynamic, these purple ones as dynamic. Okay, so for that we will actually just create, let's say we will just create a function. I have already written that so that I can explain faster. So this is the dynamic word function. This is just a component. You can place it in the components folder as well. For the simplicity, I will write every component here so that we can understand quickly. So this is a simple component. This is doing the same thing, the fetch request, and it's actually rendering the dynamic content. Okay, now if I just remove these things from here and just make it hello, and later we just place the dynamic word here. Okay, if we do that, what will happen? We'll definitely get an error, right? Look at that, an error, because we haven't wrapped it in the suspense boundary. Okay, so for that we will have to wrap it in suspense, React suspense. Okay, okay, and we can add a fallback here. And I have already created a loading component, sorry, a loading component. In case you don't understand, this is a simple loading component that just say loading dynamic word with some markup. So now, as I have already, I have removed the use cache from here. So now Next.js considered this as a dynamic page and at the same dynamic component, I would say. And as I have wrapped it with suspense, now the error will go and Next.js will be happy. Okay, so now if we go back to our diagram here, so here the thing which is happening is, suppose this is the component, this is the dynamic word component. Okay, so this one is will actually stream in. Okay, so in this page, this is a static component like Next.js 16 cache component. Okay, and this is also a static component, the green one. So these will be statically rendered when we build the page. Suppose now if I go to pnpm run build, so I will build the application. Okay, so it has already built, and let's look at this. The home page is actually having a kind of moon sign, a half moon sign. Half moon sign means partially pre-rendered. Okay, so that means this page has mixed components like partially static and partially dynamic. Okay, which are the static parts? These are the static parts and these are the dynamic parts, and these dynamic parts will be streaming in when the user requests the page, and the other parts will stay static, and this will be statically generated. If we see the definition of partial pre-render, it says pre-rendered as a static HTML with dynamic server streamed content. So it's self-explanatory. So we have HTML there, static HTML there, and also we have dynamic part as well. So we are getting the best of both worlds. Okay, fine. So let's quickly go back to our application. So now we can see that we currently know that we have a static and dynamic thing. Now, one thing I would like to mention, that just wrapping a component with suspense doesn't make this component dynamic. Don't get confused. Dynamic word, this is actually a dynamic component. We can see that it's fetching data. That's why this is dynamic. If we remove this part, okay, this part, and if we save this, and if we go there, oh, sorry, it has a data thing. So dynamic word, so make it hello. Okay, see, no error. Now the whole page will be static. If we build it again, this is now completely static. So pre-rendered as static content, the partial pre-rendering flag is gone. So Next.js intelligently knows that there is no fetching, there is no dynamic thing, and he didn't find anything dynamic here. So it rendered the page completely static. So just wrapping anything in suspense doesn't mean that it will be a dynamic component. So it only means a dynamic component if you do anything dynamic inside. So like dynamic word, inside that I have fetched the data. It can be fetching data from a database. You can query a database there. You can use access query like search parameters or anything, or you can access cookies, or you can access the header elements. Those are runtime informations. Okay, so in those cases, that component will be true dynamic, and only those true dynamic components needs to be wrapped by suspense boundaries. Okay, so now let's actually do one thing. Let's take you to the documentation first. So this is the Next.js cache component documentation. So if you search in Google, you will land to this page. So here you will see a section called using use cache. Okay, here the true dynamic means, what does true dynamic component means? So basically, we saw already that we can do any database query or any fetch request that is dynamic. At the same time, we can have runtime data like cookies. Runtime information means that user specific, like browser specific, like a user can have different cookies, like you will get different cookie value and I will get different cookie value. So those are runtime informations that cannot be rendered statically. Okay, so runtime data are truly dynamic things. And at the same time, we can have some non-deterministic operations. Like here, you cannot automatically decide whether this would be a static thing or a dynamic thing. Like for example, you can use a random number, right? So your Next.js cannot smartly detect that this can be static or dynamic, because you can keep a random number component static or you can keep it dynamic. So it's up to you. That's why you have to mark it. Okay, so let me give you an example. For example, let me first make it two components, static and dynamic, keep it together. For example, let me open the static word component. This is the static one. Here we can use the use cache to make it static component. And then we can, instead of the hello component, we can simply just call it the static word. Okay, we don't need to wrap it with suspense boundary, because this is already a use cache component. So that means it is a static component. So now I have two components, and third component that I will add, that is, let me close this. So this is a random number component. Okay, this is a random number. This is a simple function, and consider it as a separate component. You can keep it in any folder, an external file as well. So this is a component where I am just using math.random, okay, to generate a random number. Okay, and this is called a non-deterministic operation. Next.js cannot figure it out whether you want it to be static or dynamic. Okay, so you have to mark it. One way you can mark it by placing use cache. Okay, and if you don't do that and you use the random number component here, you will instantly get error. Oh, sorry, my dev server is off. Okay, see, you get the error. Okay, so it says what I just explained, that this is a non-deterministic thing. Okay, so we have to either, it has already given you instruction here. I have to make it either true dynamic, or I can use the use cache thing here, and the error will go. Okay, see, now the dynamic, this is a dynamic component, and so this is a dynamic component, and if I reload, look, the number is not changing because I have marked it as use cache. So this is a static. This is one way. And if you want to make it a true dynamic component, then comment it out, the use cache thing. And how can I make this component and tell Next.js that this is a dynamic component? Okay, here we cannot use any cookies or fetch API or anything. This is just a simple JavaScript thing, but it's non-deterministic and it's dynamic. So how can I explain that to Next.js? in Next.js, from Next.js maybe 14, we have a connection API. Okay, this is just a connection API. It actually comes from Next.js server package. And if we just give a await, if we await for the connection, then it will consider it as a true dynamic thing. Okay, so now this component is dynamic, still it will show you an error. Why? Because now the component is dynamic, but I haven't wrapped it with suspense boundary. So I will now do that. So this is the example for a non-deterministic value. Now, if I reload, you will see the random number dynamic. Now, in this page, this is a static component. This is a static component. These two are actually dynamic component, which will be streamed in when we build a production build, and even in the development version as well. Okay, so that's it. So that's what the documentation was pointing towards, that this is the non-deterministic thing. Now, we will see another thing, another example, that is the runtime data. Okay, so runtime data means cookie, header, or anything. So I will just open another example. So this is the this is the example. Okay, so consider this is another example where I have used cookies. Okay, so I will just bring the cookies function from Next.js. So from Next headers, I have imported the cookies. So here I have just used cookies, and I have extracted the theme variable, the theme value from the cookie store, and then I'm just printing that. So now we will use this here, theme info. Okay, so as we have used cookie here, and this is a runtime information, so Next.js clearly knows that this is a true dynamic thing, because it's actually a personalized thing that needs to be shown to the user. So now, if we go here, and we will definitely see an error, because yes, we need to wrap it with suspense because it's a dynamic thing. Okay, so now we will just similarly, I will do it with wrap it with suspense. So this is another example for Next.js dynamic APIs like cookies, headers, or any kind of dynamic stuffs, dynamic APIs that you are using, or you are awaiting the connection. So now the error will go. So now we'll see if I reload. So actually now this component, the theme one, this is a dynamic component. One point I would like to mention, that if you like previously, if you want to make this theme component static, like if you say use cache here, and if you remove the suspense wrapping from here, what would you think? What will happen? Actually, this will give you an error, because Next.js is 200% sure that this is a dynamic component. You cannot make it static with just, sorry, please don't annotate. So this is a theme info component which is using cookie values. So that's why you cannot make it dynamic component using just use cache. So it's actually saying that accessing dynamic data sources inside a cache scope is not supported. It is 100% sure that it is accessing a dynamic data, and you cannot mark it as a static thing. So what can you do if you want to statically render this component? In that case, you have to just take this out from you have to outsource this area to a different function and grab the cookie value and then pass it to the theme info component as prop. In that case, it will be static. Okay, so let's remove the use cache. I think this example is clear. So we have seen different, and I have to bring in the suspense as well. Okay, so what we have seen so far, you already got a bit of idea about what cache component is. Now we will actually learn one more thing, one small 2 or 3 things. Those are about revalidation. How can we revalidate the cache? Like, for example, we have some static content here. Like this is a static content, right? This is a random word, but we are getting it statically. Suppose in some areas you want to manually revalidate. For example, previously we would have used in Next.js 14 and 15, we would have used like revalidation 3000 second or this type of things. So, or do you remember that we would have used like export, constant, revalidation, this type of things? Now these are gone. You don't need to do that. Okay, we can revalidate them either time-based revalidation or through on-demand revalidation. What is time-based revalidation? That means you can say that this component, this static component, needs to be refreshed hourly or needs to be refreshed per minute. Okay, so where can we say that? For example, let's do one thing. For example, let's say, yeah.
Yeah, I'm interrupting. I'm extremely sorry, but can we just like wrap it in a bit shorter version, because I think Paul is waiting. So
Okay. Sorry. So I think
extremely
I will
sorry for
take
that.
I will just take 2 or 3 minutes.
Yeah,
Fine.
sure, absolutely.
Okay, fine. Thank you. So basically, I will just revalidate one component, then it's done. So basically, we can, this is a static component, so we would have to revalidate it. In that case, what we can do is, we can simply say cache life. This is a function. Okay, so here, if I can provide any string value, and as you can see, it's suggesting me default value is actually 15 minutes. So what is getting cached in the static area, that is actually 15 minutes cached. Okay, if you want to change it, you can just say minutes. Okay, then per minute, after 1 minute, this will be reloaded. So I will not wait for the minute thing. I will just show you the last thing, that is the on-demand revalidation. Like, for example, you don't want to do it automatically after 1 minute. You want to do it whenever you need it. So you can call a API and just revalidate this small part. So in that case, you can just simply write a root handler here, like you already know about Next.js API routes. So like, for example, I have already written one. This is an invalidate path. And here we can simply use revalidate path. We already know that about revalidate path. So I will bring it from here. So here we can simply I will just comment it out, cache life, and then I will use the revalidate path thing. So just let's say I have currently jelly here, and if I reload it, the path was revalidated, and now if I reload, you can see the word changed, and again it gets cached. So now I am manually or on demand, I am just changing just a small area of the whole page. This is actually path-based revalidation. So the entire page will be actually revalidated. If you want more granular control, you can use revalidate tag. Okay, revalidate tag. In that case, you have to just, instead of marking every page as revalidated, we can use cache tag. Okay, cache tag, and we can pass the cache tag name. Just give it a name, and I will revalidate that thing. Okay, now if I, for example, if I go here, currently it's seismic, and if I reload it, now if I go here, you will see it changed, and then it became static again. So that's it. That's what I was trying to present. So thank you, Shulagna. I'm really sorry for it was a really complex presentation. That's complex
No,
topic.
you
That's
don't.
why I had to take some time. And I would definitely thank you, everyone, and other speakers, my co-speakers as well. So thank you. Thank you, Tapushda. Thank you, Shulagna. Thank you, the organizing committee.
Thank you. But we are absolutely, I mean, we are sorry for that, for the interruption. But yes, just like, but yes, it's a great talk, a masterclass on the next caching. And thanks a lot for this great session. If you have any to the audience, if you have
Shulagna,
any
can I take
question,
just 30 seconds more? I
yes,
just
yes,
forgot one thing.
definitely,
I didn't share
definitely.
the link here. I think I would definitely share. This is the thing. This is the QR code that you can scan. There you will find my presentation, the source code I have written. I will definitely push it in the repository right now. So that's it. That's it from my side. Thank you.
Thank you. Okay, so we are very close. So we are very close to the end of the event, and to close out our speaker lineup, we are thrilled to have another incredible guest joining us all the way from US, Paul Bratslavsky. I think I haven't mispronounced his name. I'm extremely sorry for that if I did. So he's a developer advocate at Strapi and content creator of Coding After 30, and he's a firm believer of why start from scratch if you don't have to. And he will be topping on something similar that reflects the same mentality: shift faster with TanStack, Start, and Strapi. Why start from scratch? So, Paul, the stage is all yours.
Thank you for having me. I hope you could hear me pretty well. Let me know.
Yes, very much.
All right, awesome. And let me share my screen quickly here. One second. Need to give permissions to my computer. Hopefully it doesn't ask me to rejoin, but if so, I will. Apologies for that. So I'll be right back in just a minute.
I guess Paul left.
Guys, I think because of the permission that he has to give to Zoom, he'll come back.
Okay.
Yeah, it happens first time when you're trying to share on Zoom on Mac.
Got it, got it.
Hopefully he'll be back soon. Yeah, thank you everyone for staying back. অনেক রাত্রি হয়ে গেছে already.
Yes.
And yeah,
But yes, like actor for actor talk, every talk is great. No doubt on that part. And I think when you রয়ে যাওয়া and stay করে যাওয়া, this is actually, this is a great talks.
okay, I think he joined. Yeah, we have to admit him. Yeah, I'm doing it. I think Paul is here. Yeah, he's back.
Yeah.
Sorry about that. Hope you could see me now. Zoom is tricky sometimes, but I think we're back on track. Let me know if you could see my screen now.
Yeah, it's visible.
Okay, nice, nice. So let me. All right, so today I'm going to talk about shipping faster with TanStack and Strapi. And the question that I'm trying to answer is why start from scratch? I love this quote, don't try to reinvent the wheel. And this follow-up, the things you're doing, no matter how seemingly unique, have probably been done before. Take advantage and perhaps expand upon your predecessor's work. So I like this idea of not starting from scratch and using things that exist to allow you to move and ship faster. So as mentioned, my name is Paul. I work as a developer advocate at Strapi, but I wasn't always a developer, right? So I'm going to quickly share my story because this is going to set the context. And I started to actually learn to code in my late 30s. I actually didn't become a developer until I was 39. Still not an expert, just like I mentioned, switched careers. And I started a YouTube channel to kind of talk about my journey. But the thing that I really loved is having ideas and bringing them to life as a developer. And I'm going to keep this story short. I do like telling stories, so I apologize in advance. But when learning to code, I was frustrated because I didn't know how to build anything useful. At the time, I was learning React, which is mostly front end, and I didn't really know how to build full stack applications. And because of that, I didn't feel like I could build something useful. But Strapi, which is a headless CMS, empowered me to build things that are full stack where a user could access their content and allowed me to build actual applications. And why did I choose Strapi? Because it's an open source headless CMS, which is based on Node.js, and the front end is React, which allows you to make API easy. But what's cool, it allows non-technical users to easily manage their content, but as a developer, you get all that content delivered to you by REST API. So it allows you to create API minutes. It allows you to build full stack apps, use any framework that you like. I'm actually want to say, and a quick call out, that last talk about Next.js got me excited to maybe build another Next.js project. But what's awesome, this is framework agnostic. So not only can you have this power your Next.js app, your TanStack app, like I'm going to show you in this application, it could be a mobile device, or you could even send data to a smart fridge. But what's awesome, it has very low barrier to entry because you could get started in 5 minutes and have an API that you could use. So it's a very quick win, and it gives you room to grow, which I'll share more in a little bit. But I wanted to share a story that happened to me. At my first job as a junior developer, we had a problem. My CEO at the time wanted to create this product, but they didn't have enough bandwidth because this was a financial agency. They had a lot of senior engineers who were Python developers, and he literally couldn't pull them away from doing very critical tasks to try a new idea, right? And so what I propose is let me build a POC. I'm going to use a headless CMS like Strapi for the backend. And what that allowed me to do as a junior developer, it allowed me to try an idea. I was able to build a POC really fast. The board was super excited, so it got approved to build a minimum viable product. And honestly, when that idea took off, because we were able to take the MVP, put it to users, and the users was like, yeah, we definitely want this, they actually hired more developers. So even though I started the project, I didn't finish. And to me, that was exciting because it allowed us to move fast and to create something, to test an idea, even though I wasn't a senior developer at the time. And it was also easy for us to hire new developers because it's React and TypeScript. So that was really, really cool. So why is this relevant? Why this idea of shipping fast or building things important? Well, you might be working with a smaller team and you might not have as many resources, or you have cost considerations where instead of developing solution from scratch, you actually want to save time by using something that exists, which allows you to go to market faster. You're also able to iterate quicker and take your ideas and bring them to users for feedback, which improves the iteration process and allows you to not only test out your idea in the market, but also make improvements quickly. And now that we have AI, right, all these different tools from front-end page builders, from IDEs, the expectation is that we now have to get more done with smaller teams. And so today I want to share with you how I think about moving fast. What does that mean for me? And I'm going to do this in the context of the Strapi TanStack Start project that I'm working. What I love to do is to build different projects that allow users who may not be senior engineers, but beginners, intermediate, to get started really, really quickly. So today I'm going to talk about everything in the context of learning about TanStack Start. TanStack Start is amazing. I really love the fact that as a React developer, you have many different options of building things with different technologies. Like Next.js is awesome. We now have TanStack. We have React Router 7. You could even use React in Astro. And I love this flexibility as a React developer to be able to try all these different frameworks and pick the one that's best for your project and your requirements. And so for me, with all these AI tools and everything that's coming out, I started to think that the most important part of your application is your data. So don't start with the UI, start with your data and separate concerns. So the way I think about it is I have my project and I have my Strapi headless CMS as being my backend. And this allows not only me develop the project as a developer, but you could at the same time, once you, because it only takes 5 minutes to get started, you could start having your content managers or content editors managing the content, giving you feedback for your development. So as a developer, you don't just have to be the one person building out the backend, but you could also have other non-technical people having you build at least the content aspect of it. And that leaves you as a developer just focus where it matters on your front end to make sure that it's able to display that data. And so Strapi, easy to get started, and I'll talk more about this, but allows you to manage your data in dynamic zones, which allows non-technical editors really pick and choose what they want to display on the side. You get role-based access control right out of the box. It supports both REST API and GraphQL. You're able to easily query your data using the Strapi client SDK. And the part that I really enjoy about Strapi is you have full plugin ecosystem, because Strapi application is literally a React frontend with a Node backend, and a plugin is basically a miniature version of that. And TanStack Start is pretty cool. It uses mostly framework built around TanStack router and Vite. It's type safe server functions, file-based routing. And if you want something more dynamic, you could also just get stuff client side with TanStack query. And I like the fact that they go client first philosophy. And I think for beginners, sometimes jumping into frameworks like Next.js, because it really blurs kind of the front end from the back end, it could be a little bit confusing. So I like the fact that you have other options that allow you to do things in different ways. And so in my approach, I really just like to think about my data and build my AI first. In Strapi, you have a content page builder or content builder, which allows you to organize your content in ways that make sense. So in this case, I have a landing page, and I'll show you this in code as well, which allows me to add different sections like hero section, image section through this concept of dynamic zones. And a content editor could easily go ahead and pick and choose the components that they want to use to manage their content. And the idea of a headless CMS, you're not trying to manage your content that is tied to your UI, because the idea of having a content management system is because you could deliver that content to a React Native app. It could be your website powered by TanStack or Next.js, or like I mentioned before, it could be a smart fridge. So you're really decoupling your content. And what I love about this is that I have one Strapi instance that's powering multiple different apps. Once I define my data, and here you could see much clearer, here we're talking about a landing page. A landing page might have different sections. We have a hero, section heading, card grid, content with image, markdown, personal card component, and so on. And once you define your types in, here's an example of a hero section, you're able to go into the content manager and an editor. So you as a developer don't have to worry about this. Once you define the data, a content editor could easily go in and add the content. And what you get as a developer, you're able to expose the API, and you have role-based access control out of the box. So you tell what API you want. You also could say, is it a public endpoint? Is it authenticated endpoint? And this is going to kind of enable your endpoints in your application. And all of this you could literally do in 5 minutes. And once you have your API, you as a developer just get back the JSON data, which is really cool. Once you have your JSON data, right, and you want to fetch the data and make it easier, Strapi provides a client SDK that works with any JavaScript framework. And so you're able to easily basically initialize the client and then use that to get your data. So in TanStack, we use server functions. So here I'm defining a server function, and I'm basically saying, hey, let's use the SDK. We're going to fetch that single content item, which was the landing page data that I find, and then it's going to go ahead and return the data. And then in my route, I'm able to just call that data, call that server function inside the loader inside the route. And I like how in TanStack you have these kind of lines where you're like, okay, this loader is going to run on the server, and this is where I'm getting my call from. And I like, as a developer, for instance, I look at this, okay, create file route. When I call this loader, this is going to run on the server, and I'm going to use that and display that data on the client. And I have this block renderer, which I will explain in just a moment. So once you have access to your data, right, you want to display that data. And this is where I showed how I created my Strapi components. I had the hero section with an image, and so on. So the next step for me here is to map my Strapi components that you could see here on the right, for instance, hero, section, heading, card grid, and I map that to my React component. So based on the API response, using the switch statement, it's going to be like, hey, in the response, we're getting a hero section component. Let's go ahead and render it. And so by using that block renderer, based on the blocks that I get from the API, is going to render the appropriate content that I'm looking for. And I just like this simple pattern of defining your data, creating your server function to get the data from your API, and then just using it inside your route. And the one call out I want to say about this approach is, with all the different AI tools coming out, there's so many different paradigms of how do you use the data, how do you code with AI. And the one thing that I found, if you start with your data, it's much easier, and these tools are much more helpful in creating the UI. So one of the approaches that I do, once you have your API and you know exactly what the structure of your data looks like, using tools like V0 or others, you could literally point to your endpoint and based on that prompt and create this UI. In this example, I use the one-shot approach, which I don't recommend, but I just wanted to do it as an idea. I literally just said, hey, here's my endpoint, here's what I want you to do, and it was able to create this whole landing page. So if you're a new developer starting out, you have these tools at your disposal that allow you to really jump on and build something cool really, really quick. And in prompting, one of the things that I realized is that the better you understand what you're trying to build and the better prompts you give, the better UI it's going to create. And so I just wanted to kind of share this as a call out because this is something that I've been doing. It's the more context, the more you detail you give, the better your result is going to be. And here, if you read this as a human, you're like, hey, that actually makes sense. You're asking for create interfaces for 9 blocks. You're giving a little bit more details. And for hero blocks, I'm providing exactly kind of like the fields that they should include. So regardless if this is read by an LLM or read by another human developer, you kind of understand the requirements. So I like this idea, writing my prompts as if you're talking to another human, and also doing this iterative approach where here I asked it to generate all the TypeScript and interfaces for my components. And in the second prompt, I say, hey, based on the components and the interfaces that you created, go ahead and create every different block for my component. So again, I just wanted to make this call out because the AI tools exist. There is this idea of moving faster by prototyping your application through prompting, or you could do it manually. And the takeaway from working and trying all these different tools, I try to think of write your prompts as if you're talking to another person. So give as much context as you need for another person to understand what you're doing. And it's the same thing. And just to kind of point out, when I build applications, I'm trying to figure out what is the fastest way for me to move without kind of getting bogged down and out of the way with the tools that I use. So typically my setup is I use VS Code, and my VS Code has no AI. And the reason for me, at least, is because I don't want to be interrupted when I'm typing or trying to figure things out, have it autocorrect everything I'm doing. I want to make the mistakes on my own. And if I need an advice, I would use AI in a terminal. In Claude, so I love Claude actually. And the 2 ways that I use it, one way I use it in agentic mode. I basically say, hey, this is what I want to build, create a new branch and just go to town. Write all the code yourself because I'm going to review it at the end of the day. So in a new branch, it'll go ahead and create what I asked it for. And once it's done, I will review it, ask it to refactor, or I will just take what I learned from what I tried and create my own version of that. Or I use Claude as a rubber ducky where I ask questions about what I'm trying to do. But what I've noticed is understanding the tools, right? AI is not magic, and using, something like a headless CMS that's already pre-built for you, and then taking that API response and talking through it with your AI, you could quickly and easily create your front end very fast, especially for prototyping. And as a solopreneur or solo developer or someone is new, you don't have to wait too long. You could literally start building things that you could put in front of your clients, even if they're not, quite ready yet. And I'll show you some stuff in code. And another call out that I wanted to give around Strapi, it has a good plugin ecosystem and allows you to customize your applications. So I know like sometimes looking at slides is boring. So here's a TanStack project that I'm working on. And I just wanted to kind of share this quick example of this landing page that you see here. This is exactly what's coming from my landing page in Strapi. You could see all the data here. And I already showed you in TanStack Start how I get the data, but I'll quickly review this. And so in TanStack, I love this easy paradigm. Like you are able to go ahead and define different server functions. For instance, I have a function here to get the articles. I have a function here that gets the landing page data. I'm using the Strapi SDK that I already showed to you. And then wherever route expects that data for the landing page, it's in this index route, you literally just use it inside the loader. And you get the data available in TanStack through this route function here. Just say use loader data, you get the data and it's fully typed, which is pretty amazing. And another thing, what's cool is like, well, what if I want to have component responsible for your data? And in Next.js, you could have a server component that's able to just have the data. But in TanStack, it's like, you know what? It's going to be a dynamic component. It's something that I'm okay with getting client side. So in TanStack, I'll show you an example here. I have my comment section, and I'm going to quickly show you where that's located in the app. And by the way, you could check out this repo. I'll share it after the talk. But if you go to blog posts and read more, we have this comment section here. And this is going to, instead of route-based, this is component-based data fetching. And the way I'm accomplishing that in my TanStack application, I'm using TanStack query or React query, which is amazing. So basically here, I'm able to use the use query hook. And here I define what I want to get. In this case, I'm calling my get comments for articles server function. And I'm able to display it in my application here, which is pretty awesome. So not only are you able to get data route-based, but using TanStack query, you're able to get the data client side. And so for me, the simplicity of kind of like pattern of how do you fetch your data, how you get your data, allows you to quickly prototype and build out your applications. But the magic that I want to kind of share here, because TanStack makes those things like so straightforward that I almost feel like there's not much to say because of the simplicity of it. And so I do want to talk more about Strapi in the sense of here you could see that if I go to my settings and look at plugins, you're going to see that I have this Mapbox plugin and this Strapi LMS plugin, and these are not native to Strapi. This is a custom field, the Mapbox that I built, and then Strapi LMS. I was like, you know what? I have a lot of clients that are asking me to build way to manage their courses. And I don't want to constantly have a new Strapi application that I'm starting and redoing the same thing all over again. So in Strapi, you're able to take code that you find repetitive or you want to reuse, and you are able to create a plugin. So I am able to create a plugin, push it to NPM, and just literally have a user install that plugin in their application, and now they have that additional functionality that they never had. So we have this marketplace of all these different plugins that are all open source. And what's awesome with all these plugins is like you could always go in to the repo and take a look at the code that somebody made. And so I love the open source nature of it. So as a developer, if you're trying to learn how to build something, you could either, or you're not sure how to do it, you could either find a plugin for that, or you could literally dive into the code and take a look. And so here, I'll just show you a quick example. If I go to my content manager, I'm like, you know what? I want authors to be able to have a location. Currently, there is no location that I could add. And instead of adding, let's say like a field, so if I go to my content type builder, instead of in the author adding, some field that may represent that, maybe it should be JSON, maybe it should be text. And if I add a JSON field, that means my user needs to kind of add that value in JSON. And it's like, okay, you know what? Why not just build a custom field that makes it very easy for users to add location? So for this case, I made something using Mapbox, and I'm going to call this location, and click finish and save. And once it saves, we go back to our content manager. If I go back to author and open, notice now I have this whole dynamic, awesome field that's able to kind of, search locations, and much easier for users to kind of add the data in a way that's kind of nice and visually pleasant. But this functionality in Strapi did not exist, but I had the flexibility and the ability to create it as a plugin. And I'm not going to spend too much time here, but I just want to show you that if we take a look at the code of the plugin, what's cool, like I mentioned, Strapi is basically a React frontend with a Node.js backend. And so if you are a React developer, you are able to use all the things you already know to create plugins. So if we take a look at the source folder, it's structured like a normal React applications. If you take a look at the components, I created a custom field. Basically, this is my Mapbox component. What's awesome, if it does need to get some data, for instance, I needed to pass my API here and some settings. So I was able to do that by creating inside, if you take a look at the server folder, in the source, we have this ability to create controllers, middleware policies, routes. So I created a couple of routes to allow me to get certain data from my plugins that I need. For instance, if we take a look at admin APIs here I created a handler to get the search server side for the location when people are typing, but I also wanted to pass the settings for the plugin. And so I'm able to create these routes in Node.js and then consume them in my front-end application. And so the idea here is just to showcase that you're literally building mini React applications inside Strapi. So the idea that I wanted to highlight here is that as a React developer, instead of starting from scratch, you could literally get started in 5 minutes, get started with the Strapi headless CMS, and have you define all the content inside the content type builder. And then while you're working and building your front end, you now already have a functional API where a content editor could easily manage their information. And if you needed some extra components or some extra functionality, you're able to add it via plugins, which are mini React applications. And what's awesome, you could make them as complex as you want. Let me just show you a little quick example here. So a while ago, I needed to have text embeddings. I wanted to take all the content that I have in my Strapi application and create text embeddings that I could use in chatbot. So again, not a functionality that exists in Strapi, but I was able to create a plugin that uses the Pinecone database or data store to be able to add that functionality in Strapi, where I could be like, hey, here's the content that I want to make a text embedding, and now I want to have this chat interface, which will go ahead and allow folks ask questions around the content that we have in Strapi. And for me, this flexibility of being able to kind of start literally and save 10,000 hours by utilizing some of these libraries that exist. In this case, Strapi as a headless CMS. And what I like about this, when I first started learning on my development journey, I had no idea how to write custom code. I had no idea how backends work, from having controllers, services, middlewares, what are routes. I was just able to get started with Strapi and have all this available to me via API. If you take a look, I have all these different endpoints. For instance, I have article. I could say, here's the API endpoints that I want to have access to. And so very easily, I was able to get started and build a whole API. But once I improved on my development journey, I learned about creating backends. Strapi allowed me to go in and add custom code either via plugins or direct modifications, which is kind of cool. And so in kind of summary of this, what I want to say, I really love how in today's world, we have all these different things that empower you to be able to build quicker. One of the things that I like is having folks who have an idea and they just want to get started fast and build something quickly. And to me, someone who switched careers late in life, having the superpower to take an idea and build it by leveraging all these different technologies that exist, that's a superpower. And so I want to kind of share kind of my thoughts and why I rely on different tools and why I love Strapi. So in conclusion, I just want to say Strapi, it's headless CMS in nature. To me, I love separating my front end and my back end. The reason why I want to have my back end be an API that just serves the data. And I don't care if I use Next.js, TanStack Start, React Router 7, whatever the next coolest front-end framework. To me, it's almost irrelevant because I'm able to separate that concern. I also like the fact that it allows you as a developer to focus on the important parts, right? You don't need to constantly modify content. You don't need to constantly have someone call you, be like, hey, I need you to change data on my website. Let the content editors handle the content while you focus on the most important parts. And so from the start, Strapi is very easy to get started. You get full admin panel API, you get role-based access, control, you structure data using collection types, that you have dynamic zones if you want to easily give editors ability to manage their content and only show the data that they want. It's API driven. We also support GraphQL. And as you saw with different plugins, you could integrate it with any third-party service. So today we saw really good examples of different APIs using LLMs. You could actually create plugins that use those APIs directly in Strapi. And so the only one question I would say is like when to use a headless CMS, because it doesn't make sense all the time. To me, I find that I use it in 90% of my projects, but here's some of the things to kind of keep in mind is when you have a lot of content, posts, products, listing, schedule. Also, if there's going to be many people that need to manage or update that content with different permissions, or maybe you're a company that has a very small team and you can't build the whole headless CMS or a whole API backend from scratch because it's going to take time, money, and resources. And it also allows editors and developers to work in parallel. And for me, doesn't matter what I build. I always start with Strapi as a backend because I know that it'll take me hour work, like to build this whole thing out, get started in 5 minutes. And I could literally take that idea and put it in front of people to get feedback. So for me, this idea of decreased development time to try to get to market faster or get user feedback is more important than trying to build things from scratch. Because at the end of the day, as developers, I'm excited about tech. I love diving deep into learning new things. But at the end of the day, it's how are we helping businesses solve their business needs? How are we getting the application in front of users that could actually use it to solve the problem? So to me, this idea of going to market faster is almost more important than trying to kind of visualize and figure out how to build something from scratch. And at the end of the day, this also allows you just to focus on development and not content. I know I kind of went through this like fairly quickly, but if you have any questions or want ask anything about the application that I'm building, and you could go ahead and ask, and I'll share the project repo with you here in the chat if anybody's interested.
Okay. Thank you, Paul, for this great session. If you have any questions to the audience, you can just put it in the chat box and we will get the answers and get back to you. Thank you, Paul, again for this amazing session. And okay, it's an incredible evening, and we are at the very end of this entire session, entire event. And let's give one last massive round of applause, virtual applause, to all our speakers, Vishnu, Subham, Arnab, Shumidda, and Paul. And a huge thanks to all of you. This community exists because you show up, you learn, you contribute, and you bring energy every single time. Make sure to follow React Kolkata on our socials for our upcoming announcements. And this is just beginning. We will see you in our next meetup. Until then, keep building, keep learning, and as always, keep reacting. Thank you.
Thank you, everyone. Thanks a lot. Thanks, Paul. Thanks, all the speakers. Bye-bye.